So now that our EDA and the feature engineering is completed, feature scaling has been also completed. Now we will be training our model. So for this problem, this particular project, we will be applying these 6 algorithms: logistic regression, KNN classifier, naive Bayes, random forest, XGB classifier, and ANN, artificial neural network. So the logistic regression, this is the model that will be used as baseline classification model. So here we will estimate the probability of a customer of exiting the bank based on the input features. So let us begin with it. We will be keeping the details, we will see everything, we will predict the output, we will check the accuracy, precision, recall, the classification metrics, that is, the classification report, and then we will keep a record of all the performances, means performances of all the models in one data frame. Let us begin with logistic regression. So first of all, we have to import the logistic regression from sklearn dot linear model import logistic regression. This is done. Now we have to create an object for this. So lr underscore model, this will be equal to logistic regression, regression. We have to execute it, and now on this we have to fit the train dataset. So lr underscore model dot fit, we have to fit x underscore train and y underscore train. Please remember that we have already scaled this dataset, x underscore train and y underscore train. They are both the scaled dataset. This is completed. The model training has been completed. Now we will predict it. We will make prediction. So y underscore pred underscore lr means the prediction of logistic regression. We have to put the test dataset. So lr underscore model dot predict. We have to pass test dataset. Training was done on the train dataset. Prediction is being done on test dataset. Execution is completed. Now let us print it. But before printing this, we need some more. We need to import some more libraries. That will be metrics. From we will import these libraries prior to the model training only. Let us do it here. From sklearn dot metrics import accuracy, precision, and recall. And F1 score. So, okay, so this is done. So lr underscore accuracy. This will be equal to accuracy underscore score, and we have to pass it the y underscore test, which is the actual value, and y lr, sorry. So what we have done, basically we have passed the true value and the predicted value. Now this function, it will compare, means how many percentage of values it has been predicted correctly and how many have been predicted in a wrong way. Now similarly lr underscore precision. This will be equals to precision underscore score. Again, we will pass the same two variables, same two data set, not variables. This is also done. Similarly, lr underscore recall. This will be recall score. Again, same, I can paste it. And the F1 score. F1 underscore score, same data set. Okay, so this has been completed. Now let us print all of them. Simply what I will do, print accuracy is equals to comma LR accuracy, so that we can see these values. See, we have accuracy of 81% here. Similarly for precision and recall and F1 score, 1, 2, 3 and 4. So accuracy, precision, recall and F1 score. Here also we have to change precision, recall and F1. This part is completed. So we have our performance parameters here. Now let us plot the confusion matrix. From sklearn dot metrics import confusion matrix. This confusion matrix I want to display as a as a heat map. So I will import SNS and I need to import SNS and Matplotlib, but that has been already imported in my project, so I don't need to import it again. So let us see, CM is my confusion matrix. This is equals to confusion underscore matrix, and I have to pass again same two variables, same two data set, y true value and predicted value. If I print CM here, I have this confusion matrix here. Now let me make a plot for it. plt.figure fig size equals to 4, 4. Now sns.heatmap, here I have to pass confusion matrix. I want annotations equals to true, annote equals to true, fmt equals to d, and cmap. This cmap is for what are the colors that it will be taking. In this case I will pass it as blues. Better to put the three things, that is x-axis, y-axis and the title. So plt.xlabel, plt.ylabel, and plt.title. So on the x level it will be predicted value, On the y label, it will be true value, and title is Logistic Regression Confusion Matrix. So we have a beautiful plot here. I will just reduce the size a little bit. I'll make it as 3, 3. So we have this confusion matrix in the form of an array, in a form of a plot. Now what we have to do, once we are done with this, we will store the model parameters, model performance in a data set. So let us do it. We'll make a list model underscore score, model underscore results, sorry, an empty list. Now I will append here model dot append, sorry, model underscore results, model underscore results dot append, and here I have to pass it as a dictionary. So model, what is my model name? Just a second. Model is logistic regression. Model logistic regression. The accuracy, precision, recall, and F1 score. Accuracy, precision, recall, and F1 score. Here also comma is required. And the values I'll copy it from here. So LR underscore precision. Here it will be LR underscore accuracy. Here it will be LR underscore recall. And here it is LR underscore F1 score. LR underscore F1. The way we had done here. So this will be saved in this. I have put one P extra. That is why we are getting the error. Okay, so this is completed. Now in this data frame, in this list, we will keep updating our results for the other models. So this was the logistic regression. We have solved this problem. This works as a baseline model, means this works as a reference model. Now we compare that how our other models are performing, means whether it is performing better than this or is it similar to this. That way we do the analysis. So now we will do same way for k nearest neighbor. Our next model that we are going to do is k nearest neighbor. KNN classifier. So see, KNN is a distance-based classification algorithm. So it predicts churn by identifying the nearest similar data point. Okay. So let us begin from sklearn dot neighbors import k neighbor classifier. NEIGHBORS NEIGHBORS K NEIGHBOR. Here also S has to be there. Okay, now it is correct. So import k neighbors classifier. Now make an object KNN underscore model similar to the logistic regression. So here we will make k neighbor classifier Simply I'll copy it, paste it here, and this is done. And now I have to fit KNN underscore model dot fit. I have to pass train. I am training the model, right? Y underscore train. And this is done. Now same way, Y predict KNN. So KNN underscore model, which is this is the model name dot predict. What we have to pass? We have to pass the actual value and the predicted value. This is my sorry. This has been done. Missing, sorry. Here I have to pass Y underscore train. Sorry, Y underscore test. X underscore test. Okay. I'm got a little bit confused here, but now we are good. So now that this is done, again the four parameters for accuracy, for metrics, I will simply copy this and I will paste it here. So y, and here just instead of LR, I will replace it by KNN. So this will make things a bit simpler. So accuracy score, precision, recall and F1 score. Here instead of LR, I have to replace it by KNN. Basically by Y pred KNN. By this, not pred, I have written predict, so it has to be predict here. Okay, let us see. This has been executed. Similarly, I will have to print it also. The same values. So we have our results here. Now, if I want to make this graph, if I want to make this plot this confusion matrix, this also I can do. Simply I will reuse the code here. I will paste it here. Confusion matrix 3, 3. Here I will change the CMAP. Here I will use green. And instead of logistic regression, this is KNN classifier. Now let us see. I have made a mistake, means I have to change this also, right? So simply I will take it from here and I will paste it. Done. So this is my confusion matrix for KNN. Now I need to save that data into my list. So for that, model underscore results dot append. Now again it will be same as prior. Same this code has to be used. Model underscore results dot append. Instead of logistic regression, I will write here as KNN classifier. Instead of LR accuracy, this will become KNN accuracy. Instead of LR precision, there will be KNN precision, KNN recall, and KNN F1 score. Let me check my model once, what it is showing. See, so I have the data stored in it this way. Later we will convert it into data frame so that it is easily readable for us. It is very easy to analyze all the model performances, all the model results. So we will conclude for this video. The next models we'll be doing in another video, next video. Thank you.